All right, so number 19, you actually can't do this question. So we'll just cross that out. You actually can't answer letters A and B. The question is actually really poorly worded. Number 20 then. This one, identify each curve and justify your answer. You should be able to use your knowledge of polynomials. This one here is a cubic function. This one here is a quadratic function. And this one here is linear. Therefore, this one has to be the second derivative. Oh, sorry, wrong way. This one has to be the function. This one has to be the first derivative, and this one has to be the second derivative, because you always lose a power. Now, how do you justify that those are going to be your answers? You can literally do a sign chart for each of the graphs. So I look at this guy and see that I'm actually not going to create all three sign charts. I'm just going to show you that the derivative here would be 0, the derivative here would be 0. The points that correspond there would be these two. The function increases here, which is why the derivative is positive during this piece. The derivative here is negative, which means that we would go below the axis for the derivative graph. And then the last piece here is increasing, which means that the derivative is positive, which is why it's above the graph. So there is a reason why the function is letter B, and then the derivative is letter A, and then I can actually redo this using this now being the function. So take its derivative. The derivative would be 0 here, which corresponds to this 0. The function decreases here, which means the derivative has to be negative. And then the function increases here, which means the derivative has to be positive. So I visually kind of did a sign chart for you. So 21, find the equation of the tangent line at x equal to 3. So I need y of 3, which would be the point. So I get 3 times 9 minus 30 plus 5. And we get 2, I hope. 27, negative 3, 5, 2. All right. Then I need the derivative at 3. So the derivative would be 6x minus 10. The derivative at 3 would be 6 times 3 minus 10. 18 minus 10 gives me 8. So the equation of the tangent line would be y minus y1 equals the slope, f prime, times x minus x1. 22, find the equation of the normal line. Almost exactly the same question. The first thing I need to do is find the y value. So 5 pi, this would be 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So the point here would be negative 1 comma 0. The cosine is the x value, so y of pi would be negative 1. Now I need to take the derivative at pi. The derivative would be derivative of the outside, leave the inside the same, multiply by the derivative of the inside. We're going to take the derivative at pi, so it would be negative 5 sine of 5 pi. That's that same point from above. The sine is the y value, therefore now the slope is 0. So this is actually going to be a horizontal tangent. So I'm going to take this slope, which is 0. That would be a horizontal tangent. Perpendicular, which is the normal, would be that the slope is now undefined. So your equation of the tangent line has to now be a vertical line. Vertical lines have the same kind of equation. They always start with x equals. So in this case, the x was pi, and that would be the equation of the normal line. The reason is because if you look at the equation of the tangent line, which I'll do, y minus the y of the point equals the slope times x minus the x of the point, you actually end up with y equals negative 1. So the horizontal tangent line is y equal to negative 1. Again, the reason why the normal line is just an x equals equation is because the tangent line happens to be a horizontal tangent. Most tangent lines have a slope value. This tangent line had a slope of 0, which causes it to be a horizontal tangent. Number 23, find the minimum value of xy. Well, that's a minimum, and I want to find the minimum of the value, so we'll call it v, xy. This is an optimization problem. We have two variables, so I'm not allowed to have two variables, so there must be another equation to use, or more information. There it is. I'm going to simplify this so taking the derivative will end up being easy. Now I'm down to one variable. It looks a lot nicer. I'm going to take the derivative because I'm looking for a minimum. In a minimum, you always find the function you're trying to minimize, take its derivative, set it equal to 0, set the derivative equal to undefined. This can't happen. The x is now 3/8, if I did that correctly. We want to guarantee that that is definitely a minimum. So at 3/8, the derivative is 0. This is a line sloping up, so the sign chart would look like negative and then positive. So this is definitely a minimum. And the minimum value says that I have to take my x and put it into my value equation. So my value, I want to do it at 3/8, would be 4 times 3/8 squared minus 3 times 3/8. So we end up with 4 times 9 over 64 minus 9 over 8, 16. Multiply this by 2 over 2, and we get 9 over 16 minus 18 over 16, which gives us negative 2 over 16, which is 1/8. So the value, I believe, if I didn't make an arithmetic mistake, is negative 1/8. Most of you got this wrong on the test because you gave the x value. It's actually asking you for the actual value of the product xy. So